controlled low-strength materials have been referred to by many different names, including liquid dirt, controlled density fill, and fly ash slurry. However, Flowable Fill has proven to be the most widely accepted name for this proven construction material. Flowable Fill mixtures are generally a combination of cement, slag or fly ash, sand, water, and a structured air void system. Your local ready-mix producer may suggest mixes varying from these components depending on their availability and the specified project requirements. Flowable Fill is typically designed to be self-leveling and self-compacting with an unconfined compressive strength between 30 and 150 pounds per square inch. The compressive strength of Flowable Fill is measured in accordance to the same standards as concrete. However, the testing equipment utilized must be able to accurately measure strengths as low as 30 pounds per square inch. The American Standards for Testing Materials has approved 2 other test methods for strength or bearing capacity, which have proven to provide more precise and accurate results. The preferred method for testing bearing capacity is measuring the penetration resistance. It's important to remember that flowable fill is an alternative in lieu of traditional granular fill or dirt. A compressive strength of 50 pounds per square inch is equivalent to 7,200 pounds per square foot. In contrast, traditional compacted fill material will usually not obtain more than 2,500 to 3,000 pounds per square foot. Now that's even after time-consuming and costly compaction measures have been taken. Performance tests may be required prior to placement to establish strength gain performance for the mixture. Once the mixture has been pre-approved, acceptance is commonly based on confirmation of the batching recordation.
Originally, when we started experimenting with flowable fill, the city requested that we do a 50-unit test, backfill 50 holes and then see how well they hold up. And then based on the results, they would either approve it or tell us to go back to whatever methods we had been using. So we gave them a complete list of all the cuts, and they went out and looked at them, and everyone was perfect, so they were thrilled with the results.
Besides compressive strength, flowable fill has many other properties that enable the contractor to meet project specifications. Flowability is a measure of the flowable fill mixture's fluid characteristics. Depending on the application, the flowability can vary from a very stiff to a very fluid consistency. Highly flowable mixtures often contain a great deal of water, and therefore considerations for hydrostatic pressure during backfill applications should be evaluated. Placing flowable fill in lifts, with each lift being allowed to harden prior to the next placement, will reduce hydrostatic pressure.
Buoyancy is a common concern when using flowable fill to backfill any pipe. As seen here, the flowable fill mixture has been placed at a fairly low flowability to prevent the tanks from floating. Contractors have developed numerous other methods to reduce the possibility of floating pipes. Excavatable flowable fill has been defined by the National Ready Mixed Concrete Association as having a maximum compressive strength of 150 pounds per square inch at 1 year. Strengths exceeding this limit have been known to be excavatable with the use of mechanical equipment. However, tests indicating the ease of excavatability should be made prior to final placement. Flowable fill mixtures can be designed to range in permeability from that of a uniform coarse sand to that of a clay material. This versatility in design offers numerous advantages over local site material and does not limit the engineer. Flowable fill mixtures are typically designed to reach a unit weight between 70 and 145 pounds per cubic foot. The use of special flowable fill admixtures can reduce the unit weight to as low as 20 pounds per cubic foot.
Flowable fill mixtures offer numerous advantages when stringent design criteria must be met.
The major advantage in flowable fill is how quickly you can get the backfill in place and get the surface restored.
We bid the job as a 3-week project. By using flowable fill as a value engineering item, we were able to shorten the duration to 1 week.
The self-leveling and self-compacting characteristics of flowable fill ensure 100% compaction. even in areas that traditional granular fill would prove impossible to compact.
Wherever we use flowable fill, we don't have to use any other compaction equipment because it develops a 98 to 100% density just as soon as you pour it in the hole.
Now, the most common problem, according to the Public Works Association, is the all too common callback.
Ever since 1990, we've been watching, and we've never had to go back on one that had flowable backfill in it.
In the past, we would make an excavation, backfill it with the granular material, finish our cap, then we would come back 30 days later to inspect that trench to make sure it was not settling. We found that we were going back 60% of the time to restore a trench that had failed. By using flowable fill, we reduced that return time to 0.
Traditional compacted fill requires skilled personnel, equipment, and time to properly place, compact, and test the material. Oftentimes, there's a disruption to traffic, causing congestion and delays to the public. Time is limited when repair work is being performed in an emergency repair roadway cut. And as a result, quality compaction is often sacrificed, resulting in another bump in the road. Flowable fill does not settle. Once the mixture has undergone initial subsidence, now that's approximately 1/8 inch for every foot in depth while it's in its plastic state, further settlement will not occur.
Since traditional compacted fill requires operating compacting equipment in the trench, the contractor must implement additional safety measures to ensure the safety of the workers.
If we had a 6-foot trench, of course, we had to make 3 applications of the sand and compact it all the way up. By using flowable fill, we've basically reduced that. We pull all the shoring, we pull all our labor out of the trench, we bring the trucks up on the job site, and we start pouring the flowable fill. It migrates around the pipe, it migrates back into all the crevices, and we gain that 95% sanded proctor every time we make a backfill.
Recycling fly ash into flowable fill actually improves the quality of the product, while providing an alternative to simply landfilling the material, thus helping to improve our environment.
Flowable fill, unlike traditional compacted fill, does not require on-site storage or ideal weather conditions during placement. Flowable fill allows for year-round construction.
With flowable backfill, we can use it in any weather. It doesn't matter, rain or shine or snow or freezing conditions.
Flowable fill provides contractors with numerous opportunities for cost savings. For starters, most flowable fill projects require less manpower, such as laborers, equipment operators, and QC technicians. And finally, the amount of material to be excavated is greatly diminished, which also reduces on-site storage requirements.
New laws enforced by the Environmental Protection Agency concerning the abandonment of fuel tanks have sparked an increase in use of flowable fill in many underground applications. Abandoned sewers are easily filled with flowable fill, which provides adequate strength to support the surrounding soil conditions. Flowable fill has been widely accepted as a backfill material along utility trenches by many state public works departments.
We have not ran across any problems with using this product. It works good, especially around our duct lines and our steam lines that we've used this product around.
Water main breaks are very common in all metropolitan areas. These repairs require immediate attention and often result in lane closures and traffic congestion. The use of flowable fill does not require the contractor to interrupt the traffic flow. Steel plates spanning the open trench allow vehicles to continue to pass while flowable fill is filling the trench below. Flowable fill utilized in residential construction eliminates settlement problems and ensures sufficient compaction.
The future of flowable fill is very promising. Some states, such as Iowa, North and South Carolina, Massachusetts, and Rhode Island, have been using flowable fill for many years in applications including soil stabilization, erosion control, filling voids, pavement base, bridge conversion, and similar projects. The possibilities are endless. Flowable fill provides superior performance and at a very economical bottom line. For more information on flowable fill, call the NRMCA at 888-84-NRMCA. Before you backfill, consider Flowable Fill.